question number 3. So let me see what is the question number C. So in this question we have to find out this one, d dx of 0 to root x cos t dt, and this is first using the method that evaluating the integral and then differentiating the integral. Okay, so let's see. F, let us write f of x as 0 to root x cos t dt. So cos t dt is okay. Cos t dt is always, I mean, in real line it is continuous, so we can use the fundamental theorem of calculus, and you can actually take gx to be sin t, then g dash x is equal to cos t. So using the fundamental theorem of calculus, this will be g of root x minus g of 0. So this will be sine root x minus sine 0. Sine 0 is 0. So this is my fx, and if you differentiate dx of fx, you will get the dx of sine root x. So now is the time to revise chain rule. So let's write chain rule. Okay, so take g to be what, gx to be root x and fx to be sin x, then f composition gx will be f of gx is root x, and then small f of root x, this is sine root x. Okay, so this is our function, and now I am saying that what is our chain rule? If g I to j and this I to j is differentiable on I and g, f from j to r is differentiable on j, then f composition g, which is from I to r, this is differentiable, and the difference and f of g dash x is equal to f dash gx g dash x, right? So time to, so our this sine root x, in our case gx is root x and fx is sine x, and f composition gx is f of root x sine root x. This is what we want. Differentiation of sine root x, differentiation of sine root x, this is equal to this differentiation of f dash, and then input the value gx and then g dash x. So what is actually from here, g dash x is equal to half root x. This I'm using the fact that x to the power a differentiation is a x a minus 1. Yeah, so by this thing we are getting this thing u dash x, and obviously f dash x is cos x. So now just you fit it into this formula, you will get g dash x is 1 by 2 root x, and then gx is f dash of gx is what, root x. So then f dash of root x is cos root x. So this is our answer, cos root x by 2 root x. Yeah, so we have got our differentiation of fx. This is the answer. Now we have to do the same question in different way, and that is by using the fundamental theorem of calculus. Okay, so pay attention to this one. Okay, so the same question, d dx of, let me just copy this thing, copy, paste. Okay, so we have to differentiate this thing directly. Okay, so let me write, I am defining f of ux as what, I am defining as 0 to u x cos t dt, and ux is my root x. Okay, so what is u dash x? This is 1 by 2 root x, and now see that fux, this is actually 0 to ux cos t dt. Cos is integrable, I mean cos is continuous function. So now I'm using the fundamental theorem of calculus, this one. Sorry, why am I erasing it? Yeah, okay. So this fx is equal to a2x ft dt, and f dash x is equal to small fx. So whatever is inside. So here I am using, our f is a function of ux. Here it is yeah, from a to ux, this cos x. So f dash of ux will be small f ux, right? So that's what I am going to use here, that f dash of ux, I am differentiating with respect to u. Okay, so this will come out to be small f cos ux, right, using that fundamental theorem ftc, first part, fundamental theorem A. So here this differentiation, sorry, this differentiation, this dash is with respect to ux. Okay, so this will come out to be cos ux. Okay, now what do we have to do? We have to find d dx of 0 to ux cos t dt, which is d dx of f of u of x, which is f composition u. So we call your chain rule, we can write this is f dash of ux, then u dash x, and then f dash of ux we have already calculated it out here, just put it directly, cos ux, and u dash x also we have calculated, it is 1 by 2 root x, and so cos ux is actually root x, so cos root x by 2 root x. Okay, so now actually you can see that this thing by method 1 and method 2 we are getting the same result. Okay, so that's it for question number 3a. I want you to try 3a 3b on your own using the same method.